Hello everyone. This video let's learn independence and dependence event and their probabilities and random variables. First, independence and dependence. The event E and F are independent if any of the following three conditions are true. P of E given F is equals P of E. So what's the meaning of this equation? It doesn't matter if I have the given information or given condition F. It doesn't matter we have F or not. So the probability of the event E occur equals P of E, equals itself. Okay, let's see the second equation. P of F given E equals F. That means it doesn't matter if I have the E happened or not. So P of F given E equals P of F. The probability of the event F happened. It doesn't matter about the given condition E. And P of E and F equals P of E times P of F. Let's see, events that are not independent are dependent, or if an event is not independent, so the event is dependent. So P of E is 0.5, P of F is 0.6. So by the third condition we have learned, if P of E and F equals P of E times P of F, then we say these two, they are independent event. Okay, P of E and F is 0.3. Okay, we can put 0.3 here, equals P of E times P of F. P of E is 0.5 times 0.6. Yes, the left-hand side is 0.3 and right-hand side is also 0.3. So E and F, they are independent, satisfied the last condition. Okay, independent. Let's see if I can verify that the second one is if P of A and B equals P of A times P of B, then they are independent. Let's see this is equal or not. Okay, P of A and B is given is 0.4. Can I say it equals P of A 0.7 times 0.6? No, they are not equal because the right-hand side is 0.42. So they are not equal. I must say they are dependent two events. Okay, let's say they are dependent because it's not equal. Oh, this is A and B. So in the normal life, in the daily life, a lot of events, they are independent. I don't prove they are independent. For example, if you are flipping a coin, the tails and heads, getting a tails or head. So flipping a coin, this is the dependent event. And also if I have dice, the fair dice, so you have, for example, you have 3 here, you have 1 here, you have 2 here, or 4, something like this. This means flipping a toss a dice, this is independence event. Because, for example, if you get a 1, or you flip you toss a dice, you get a 2. So getting a 1, this event, and getting a 2, they are independent. You are not at the same time getting both numbers. All right, odds and probabilities. The odds in favor of an event E is the ratio of the probability that E will occur to the probability that E won't occur. So let's use math. You use a math word to describe the meaning. Odds in favor of E equals probability of the E will occur, and 2. So these two dots means 2. P of E prime. E prime is the event E will not occur. Probability of the E will not occur. Or you can write it like this way, P of E to P of E prime. The odds are usually expressed as a ratio of a whole number. For example, you have 2 to 3 or 7 to 4. You are not having 0.7 to 0.4. You are having whole numbers. You can convert this one to be 7 to 4. So make a whole number to a whole number. Okay, P of E equals 2 over 5. Then find the odds in favor of E. We know that the odds in favor of E equals P of E to P of E prime. What is a P of E prime? We learned P of E prime equals 1 minus P of E. It is 1 minus 2 over 5. It is 3 over 5. So P of E, 2 over 5, 2, 3 over 5 equals, so this is a fraction to a fraction. We can do the cancellation. Denominator, they are the same. We cross out the denominator. So we are having 2 to 3. Solution is 2 to 3. Next example. The odds against an event E is the ratio of the probability that E won't occur to the probability that E will occur. That's the reverse way or the opposite of odds in favor. For example, the reverse of the odds in favor. Okay, reverse of the odds in favor. Odds against E, P of E prime to P of E, or P of E prime to P of E. For example, P of E is 3 over 7. Let me ask you, what is P of E prime? Use 1 minus P of E. It is 4 over 3 over 7. So use 1 minus 3 over 7. Okay, odds against E, it is P of E prime to P of E. That is 4 over 7 to 3 over 7. It is 4 to 3. Okay, sometimes you will want to go from odds to probability. If the odds in favor of E is A to B, then so the odds in favor of E is P of E divided P of E prime. It is A over B. So the denominator P of E prime is 1 minus P of E. That is also A over B. If I do the cross multiplication, if I do this, then P of E times B equals A times 1 minus P of E. Okay, if I'm going to simplify that, we are having A plus B times P of E equals A. And also, I can isolate P of E. Equals divided by A plus B both sides. We have A over A plus B. Okay, if I have odds in favor is given, or the odds against E, the ratio is given, then I can plug in A and B's value, find P of E or P of E prime. For example, odds in favor is 4 to 7. Okay, we have learned is A to B. and then find the P of E. So P of E, we already did the conclusion of the formula P of E. If the A and B, they are given A divided by, so 4 divided by 4 plus 7, it is 4 over 11. Okay, let's see. Random variable. A random variable is a variable whose value is determined by the outcome of an event, of an experiment. For example, flip a fair coin twice, and let x be the number of tails that occurs. So, number of the tails that occur, tail occur, not the x should be a number, for example, 0, 1, 2, 0 or 1 or 2. Okay, so let's see the sample space. S equals, the first flip is heads, second flip is heads, or first flip is heads, second is tail, or tails, heads, tails, tails. I can only have these 4 outcomes. Okay, let me ask you, if my experiment doesn't have any tails occur, so this is my first case here. It doesn't have my tails occur. So the numbers of the tails occur is 0. And next one. So how about if I flip the coins twice? I only have 1 tails. So you see, these 2 outcomes has only 1 tails. So the numbers of tails that occur is 1. And the last one, the tails happen twice. That means numbers of the tails that occur, the number is 2. So the random variable of the x is 0, 1, and 2. Probability distribution of a random variable. It is a table of all values of random variable along with their associated probability. For example, still we're using the previous example. Using the previous random variable, sample space S is HH, HT, TH, TT. The top, they are the random variable X. So the tail happens once. Happens 0 times. So this outcome has no tails. That means the tails, numbers of tails is 0. And what is the probability? We have learned P of x equals N of x divided by N of the sample space. Sample space has 4 outcomes. And how about the N of x? It is 1 because only this one event has no tails. So it is 1/4. And how about appear 1 time? The tails appear 1 time. These 2 events has 1 tails. That means 2 over 4. So P of x is 2 over 4. Let's put 2 over 4, which is 1/2. Let's simplify the 1/2. So this is 1/2. And the last one, if the tails happen twice, number of the tails has 2 times. So this one. So let's see which outcome has 2 tails. Last one. Last one is the number 1 over 2. So the sample space is always, number is always 4. The top TT happened once. So 1 over 4. Let's put 1 over 4 here. All right. Let's see. Histogram of random variable. I don't have to use a table. I can also use histogram. It's a special bar graph of the probability distribution where the bars are centered at the value of the random variable. Adjacent bar touch and the area of the bar is equal to the probability that the random variable takes on that particular value. So convert the table to the histogram. Okay, the horizontal bar represent the random variable. So let's let's put RV, that's random variable. So in the middle, or all of this bar represent the random variable equals 0 and the vertical line. So this represents the probability. So the probability of random variable is 0 is 1/4. And when the x random variable is 1, the probability is 1/2. When the random variable is 2, the probability, let's see, is 1/4. Okay, expected value of random variable. For x random variable with probability distribution, at least all of the random variables on the first row, and then the probability of each random variables in the second row. The expected value of x, we called e of x, is defined as e of x equals x1 times p1 plus x2 times p2 plus x3 times p3, and then plus x4 times p4 plus etc. plus xn times pn. For example, if I'm using this formula to find the expected value of x, or we say e of x, the given table, we have the random variable on the first row. Second row, they are the random variables probabilities. So the e of x is 0 times 1/4 plus 1 times 1/2, 2 times 1/4. So first term is 0, and 1 times 1/2, 1/2, plus 2/4. It is 1/2 times 1 plus 1/2 is 1. Okay, probability, expected value of x is 1. What does e of x mean or represent? The expected value geometrically is the balance position of the histogram. Okay, let's see. Okay, let's see this histogram. Where is the balance position? Is here. So the expected value is 1. More practically, it represents the long-term average value of x. If the experiment is performed n times, with x taking on the values x1, x2 to xn, then the average value of x would be x1 plus x2 plus plus xn divided by n. For large value of n, the average value of x will be close to e of x, the expected value. The bigger n gets, the closer the average value of x will get to e of x. So in our example, if the experiment of flipping a fire coin twice and recording the number of tails is done a bunch of times, the average number of the tails per trail will be close to 1, because here we found the expected value of x is 1. So in the long run, each time I flip a coin twice, in the long run, the average would be 1. So it will appear 1 time in each flip. Not each flip. Each time I did this experiment, because I flipped twice. All right, let's see the example. In the game, you roll a fire die. If you roll a 1, you win $1. If you roll 2, you win $2. If you roll 3, you win $3. If you roll 4, 5, or 6, you win nothing. Determine your expected winnings from one play of the game. Let x be your winnings from one play of the game. Okay, what is the top of my row, or what is the random variable? So x is you are winning from one play of the game, how much money you may win from one game. So you may win $1, or you may win $2, you may win $3, or you may win nothing. That means $0. So the first row, they are the outcomes of the experiment is maybe you win $1, maybe you win $2, maybe you win $3, maybe you win $0. And for winning a $1, what is the probability? Because we only have one outcome out of 6 numbers in the sample space. Sample space we're having 1, 2, 3, 4, 6. So it is 1 out of 6. The second one, if you roll a 2, then you will win $2. So how many 2s do we have on the fair die? We have only 1 2. So it's 1 outcome out of 6 faces. And how about 3? If you roll a 3, you win $3. That means 3 only appears on the fair die on one side or one face. So it's 1 out of 6 outcomes or 6 sample space numbers. How about 0? So if you roll a 4, 5, so you see 4, 5, or 6. That means I have 6. We have 3 out of 6, which is 1/2. We can make it simple. 1/2 probability. If you roll a 4, 5, or 6, that means you win nothing. All right, what is the probability? The probability formula is 1 times 1, 6, plus 2 times 1 over 6, plus 3 times 1 over 6, plus 0 times 1/2. And add them together, we are having 1 over 6 plus 2 over 6 plus 3 over 6, and then it is 1. Okay, in a long run, if you flip so many times, the average of winning per row or every time, you will get $1. Let's see second example. In a raffle, there is one prize of $1,000, 2 prizes of $500, 4 prizes of $250, and 10 prizes of $100. 1,000 tickets are sold at $10 each. So they are selling raffles. Are they making money? Yes, they must make some money. Okay, the prize are awarded by randomly selecting a ticket. Determine your expected net wins. So let me ask you, how many numbers or how many outcomes in the sample space? I'm asking you, how many raffle tickets are there? For example, in the big jar. I have a big jar, and then in this jar, I have so many raffle tickets. So how many raffle tickets do we have in this sample space? So we are having 1,000. So N of S is 1,000. What is a sample? What is a random variable? Random variable X is your net winnings from one ticket. So buying a ticket, I will spend $10 each. And 1,000 tickets, $10 each. If, for example, if I can win $1,000, but I still need to pay $10, that means I'm going to win. This money is $1,000 minus the money I spend to buy these tickets. And if I can win $500, I still need to pay $10. So this $490 is coming from 500. I got the second biggest price, minus 10. And the $240 is coming from the 250 minus one ticket's price. And then $100 minus $10, that is 100 win this price. And then I need to spend $10. Totally, I can win $90. And the last one is I may lose $10 of buying the ticket, but I win nothing. So the last one is $10 because I win nothing. I didn't get any of the price. Okay, let's see the probability. How many of the tickets can win $1,000? That is only one ticket's total sample cardinal numbers of the sample space is 1,000 tickets. So 1,000 over 1,000. How about if you can get for $90? So we have two prices. So look at the question here. I have two price. The prices can win $500. That is 2 out of 1,000 tickets. And then 4 prizes. So 4 out of 1,000. And then $100 the price. We are having 10 tickets. 10 out of 1,000. How many of the people win nothing if from the big jar? So big jar we have 1,000 raffle tickets, and one person or one ticket is $1,000. 2 tickets is $500. 4 tickets also has a price, $250, and 10 tickets, it is $100. That means rest of the tickets has nothing or has no price. That means I'm using the 1,000 tickets minus all of the tickets which has a price. 1 plus 2 plus 4 plus 10. So 1,000 minus 17. It is 983 tickets has nothing. Okay, let's see what is the expected value. We're using 990 multiplied by 1 over 10,000 plus 490 times 2 over $1,000 plus 4 times 240. 240 times 4 divided by 10, 1,000 plus 90 times 10 over 1,000 plus negative 10 times 983 over 1,000. We can use our calculator to help us to find the expected value. And then I got negative 6. So negative 6 means negative $6. That means I'm losing. I'm losing $6 each time I'm buying a ticket. Or each play. So each play, I'm going to lose $6 per playing. In the long run, the average is losing $6 each play. That means the people who is selling the raffle tickets, they are getting a lot of money. Because one person will lose $6 or one play will lose $6. And we have so many players and so many plays. Okay, let's another option, solving this one. If my random variable, I didn't choose 990 here and 490 here. So the first row, the random variable, I'm going to say, this is the money I'm going to win without thinking of buying a ticket. For example, the Y equals $1,000. The probability is 1 over 1,000 because only one ticket has $1,000. And 2 tickets out of 1,000 that had $500. And 4 tickets has $250 price, and 10 has $100. So 10 out of 1,000. And rest of the tickets they have no money. So we did the computation. That's 983 out of 1,000. And then yes. And then what should I do? I'm going to find E of Y. E of Y is 1,000 times 1 over 1,000 and plus 500 times 2 over 1,000 plus 250 times 4 over 1,000 plus 100 times 10 over 1,000 and then plus 0 times 983 over 1,000. So let's do the computation. Is 1 plus 1 plus 1 plus 1. Okay, I'm going to win $4 if I pay nothing in the long run. For example, this 4 means I'm going to win each play. In the long run, the average is $4. But what is the problem? Each run or each time I'm drawing a ticket, I must pay $10. So I must use my $4 here. Minus each time I'm going to pay for playing. So it is -$6. That means I'm not going to win $4 in the long run each time or each play. I must also pay $10 of playing. This means in the long run each time I'm going to lose $6 per play. Okay, it's an interesting question. Let's see next example. A 25-year-old can purchase a 10,000 to 1-year life insurance policy for $100. The probability of a person dying at age 25 is 0.002. Determine the expected profit to the insurance company from the sale of one policy. If you see this, expected something, that means we're looking for the expected value. Okay, excuse me. I'm going to list the random variables on the first row and its probability in the second row, and then we can find the expected value. Let X be profit from the sale of one policy for the insurance company. Okay, X will be the profit. So how much money the insurance company will make? For example, unfortunately, this person died. And then this person, he paid the insurance company $100 for buying this policy. But the insurance company will pay his family, $10,000. That means how much profit the company will make. I'm using, so this one is using $100 the company will make minus the $10,000. That is the money the company will pay for the family. So lose this money. And how about this person didn't die? That means the person will buy this policy without any return. So the company will make $100 from this person. So this is making money, the profit. What is the probability of losing this amount of money? So here, losing the money, a person dying at age 25 is 0.002. That's a probability of losing money. Okay, how about making money? So what is the probability of the person will not die? That is 1 minus 0.002. So let's use our calculator to find the probability. It is 0.998. Okay. What is the probability? What is the expected profit of the insurance company? The formula is using negative 900 multiplied by 0.002 plus $100 and then times 0.998. Some of the book doesn't have a zero here. It's okay. All right, let's use the calculator to find the number. Okay, it is $80. Okay, what's the meaning of this $80? So if the insurance company sell many of these policies, then on average, the profit or their profit per policy will be about $80. All right, the company will make a lot of money because the probability of dying at 25 is very minimum, very small. Then the expected profit of the insurance company are a lot because one person, the company in the long run will make one policy. On average, the company will make $80, and if they sell a lot of policies to people, they are making a lot of money. Okay, determine the expected value of the random variable with following histogram. Okay, this question, if we have a table, I know how to find the expected value. We're using the random variables multiplied by the probabilities. So in the histogram, we have learned the horizontal, they are all the random variables. And vertically, so here, this represents the probability, for example, is 1/10, and this is 2/10 or 3/10, something like this. But now I don't have the vertical numbers, the vertical line. It doesn't show me any information of each variable's probability, how to find the expected value. But we have learned the horizontal balance position of the histogram. That represents the expected value. So we learned find a balance point or balance position. Where is that balance position? Okay, here you see this graph is symmetrical along this value. I am thinking this value is 5.5. So this is a balance point. My graph is symmetrical along this point, or this is the balance position. So I'm going to say the E of X or expected value is 5.5. Even I don't have my table, but I can tell from the balance point. Okay, this is the last question.